Okay, so for today we are going to talk about 1000 solved integrals, no? 1001 solved integrals part 1. So basically I'm making a video of a 1001 solved integrals, but this will be only the part 1. So that I will be having many videos to be uploaded about the solved integrals. So I'm trying to make integrals as easy as possible for the students so that they will not be afraid of the integrals when they encounter this in their college life or in their engineering life as they take integral calculus 2. And also, this is also good for those who want to be refreshed with their integrals. Um, Most probably, I'll be making 100 videos about this. So I don't think that this would be really easy for me, but I'll try my best, okay, in my agenda to basically solve 1001 problems in terms of integrals. So I'm just thinking also of uploading also 1001 solved problems in differential calculus or differentiation, or in differential calculus, as well as 1001 solved problems in differential equations. So, but that is only my plan alongside with the other uh, subjects that I'm planning to upload, such as the major subjects, mechanics, and even algebra. Okay, so that we could start with the basic. So please help me in my goal to actually reach this 1001 solved integrals. By the way, the calculator techniques, engineering mechanics, statics, dynamics, strength of materials, electrical circuits, electronics, I'll still be continuing to upload on those things. Okay, most especially in advanced math also, and in other parts or in other topics of differential equations. And I'm planning to build this channel as the ultimate engineering channel, okay? So that the students would have a free access, in learning um, math courses or even major courses belonging into their course. So without further ado, let's start our part 1 with the 1001 solved integrals. So for our first problem, we need to integrate pi dx. Okay. So we need to integrate pi dx. So basically, if we are going to integrate this, the constant rule tells us that we can factor out constant outside of the integral sign. So we can factor out pi because that's a constant. Okay. So and definitely integrate dx, and that is pi x plus c. Okay. So don't be afraid when you see something pi inside the integrals. The rule is that we can actually factor it out outside of the integral and proceed with the integration of whatever is inside the integral. If that is multiplied, of course, in the integral. So for number 2, we have to integrate 3 all over x raised to 8, plus we have e, the number e, okay, and then we have 8 root of x cubed. Okay, and then we have dx. So by properties of integrals, since this is sum and difference, or sum, we can actually factor or rewrite this integral as the separate integrals, as separate integrals. So we have 3 all over x raised to 8 dx, plus we have the integral of 8 root of x cubed dx. So again, applying the properties of integral, we can factor out 3 outside of the integral, and we can raise x raised to 8 by negating its exponent, so that we can use power rule here. And of course, also in here, we can factor out e because that's constant number. And then what are we going to do with the denominator is to convert it always into exponential form. Okay? So it's in radical. So we can convert it into exponential. So we have x raised to 3 all over 8. Okay? So that would be our integral. So again, let me just rewrite this. So what can we do is actually what we did on the first term, we can do in the second term, so that we can negate its exponent and rewrite this as this, x raised to negative 3 all over 8, and then dx. Okay? So what are we going to do? We are going to solve it. Okay? So this would be x raised to negative 8 plus 1 all over negative 8 plus 1. Plus we have power rule. Okay? So we have x raised to negative 3 8 plus 1. X raised to negative 3 all over 8 plus 1 all over negative 3 8 plus 1. Okay? Plus c. So basically we have 3. And then we have x raised to negative 7 all over negative 7. Okay, for our answer here. Then we have plus e. So we have to calculate negative 3, 8 plus 1. So cross multiply. So we have negative 3 plus 8 all over 8. Okay, and that becomes 5 all over 8. Okay, so we have x raised to 5 all over 8 all over 5 all over 8. And then plus c. And upon uh, substitution or upon simplification, we have negative 3 all over 7 x raised to negative 7. And this would be we would be getting the reciprocal of that. Okay, so that we can proceed with multiplication. Okay, with x raised to 5 all over 8 and multiplying it by e. So we have 8 all over 5 e multiplied by x raised to 5 all over 8 plus c. Okay, and we don't want, of course, we can take this as our final answer, but it's actually a good practice to eliminate negative exponents. So if this is a negative exponent, x raised to negative 7, we can get the reciprocal of that by negating again the exponent so that it becomes negative 3 all over 7 x raised to 7 plus 8 all over 5 multiplied by e multiplied by x raised to 5 all over 8 plus c. And that is our answer for number 2. So, we still have 998 integrals to go. Okay? But I will be doing all of the 1001 integrals here. Alright? So, it would be in different videos. So, maybe in this video, I could make 10 problems. Okay? So that for the next video, it's always 10. Okay? I'll try my best to upload integrals always in 10 problems. So we will be having part 100. Okay? Because 100 times 10 would be 1,000. Of course, one part would be 11 problems so that I can finish the 1001. Okay? So, how about the integral of 3x squared minus 4x plus 8 all over x raised to the 5? X raised to 5. No? So, we can factor out 3x squared all over 5, x raised to 5, by properties of integral again because this is sum and difference. So, we have negative dx. So, minus, because of the minus sign here of the 4x, integral of 4x all over x raised to 5 dx plus integral of 8 all over x raised to 5 dx. So, as you can see, this would cancel with, we have x squared all over x raised to 5, that's x cubed. X would cancel here, this would be 4. So, and then we can factor out some of the constants. So, we have 3, we have 4, and we have 8 outside of the integral side. So, if we do that, we have 3 integral of 1 all over x cubed dx minus 4 integral of dx all over x raised to 4 plus 8 integral of dx all over x raised to 5. And again, we can negate its exponent so that we can use the power rule. Oh, I don't have dx in here. I forgot dx in here. So we have dx in here plus 8 integral of x raised to negative 5 dx. So if we're going to calculate this, so this would be what? 3 x raised to negative 3 plus 1 all over negative 3 plus 1. Then we have minus 4. Then we have x raised to negative 4 plus 1 and negative 4 plus 1 here plus 8. And then we have x raised to negative 5 plus 1 all over negative 5 plus 1. So simplify. So we have 3. We have x raised to negative 2 all over negative 2 here minus 4. And then we have x raised to negative 3 here and all over negative 3 plus 8. Then we have x raised to negative 4 all over negative 4 in here. So we have negative 3 halves x raised to negative 2 And then we have negative 4 multiplied by this negative, that becomes positive. So we have plus 4 all over 3, x raised to negative 3. Okay? And then we have 8 divided by negative 4, so that becomes negative 2. Negative 2x raised to negative 4 plus c. So this can be our final answer, or we can wish to eliminate the negative by negating it. So by getting the reciprocal of it, so we have negative 3 all over 2x squared plus we have 4 all over 3x cubed minus 2 all over x raised to 4 plus c. So that can be also our final answer. Okay? So that is for number 3. So how about for number 4? For number 4, we have the integral of 3x plus 1 and we have x plus 2 squared dx. So as you can see here, we cannot use any substitution method, use substitution, because um, there will be no factor of u. Okay? So we have no other choice but to expand this. So if we expand this, x plus 1, x plus 2 squared would be expanded as x squared. Okay, and then multiply x by 2, that's 2x, and multiplied by 2, that is plus 4x. That's how you get the middle term. And for the last term, you square the last term here for the binomial. So 2 squared would be 4. So that's the expansion of our binomial. So again, we can distribute. Okay, since this is multiplication, we distribute this. Okay, and we have no choice. Okay, so because we don't have any let's say techniques that we can apply here. Okay, so we have to distribute that one by one because that is multiplication. So we have 3x times x squared, that's 3x cubed. 3x times 4x, that's 12x squared. 3x times 4 would be 12x plus, of course, copy. 1 times x squared, we will be having x squared plus 4x plus 4. And then combining like terms, okay, so we don't have any cube, so that's still 3x cubed. Okay, how about for the squared? We have 12x squared and then we have x squared, so we have 13x squared. How about for x? We have 12x and then we have 4x. So we have plus 16x. And any constant number we don't have. Okay? So that must be our solution. Okay? Our solution for this. 16x plus 4. Okay? So by properties of integral, we can now factor out. We have 3x cubed dx plus we have 13 x squared dx plus we have integral of 16x dx plus we have the integral of 4 dx. Okay, factoring outside the integral sign, the constants. So you always do that because that would make your integration much more easier. Okay, so you can only factor out constant outside if they are multiplied. Okay, so we have 3 x raised to 3 plus 1 all over 3 plus 1. That's the integral of x cubed. Power rule plus 13. And then we have x2 plus 1 all over 2 plus 1 here. Plus we have 16 x raised to 1 plus 1 all over 1 plus 1 here. Then we have 4. Integral of dx is simply x. Okay, plus c. Don't forget the plus c. So we have 3. Okay, 3 x raised to 4 all over 4 plus we have 13 x cubed all over 3 plus we have 16 x squared all over 2 plus 4x plus c. So as you can see, we are going to simplify 16 all over 2. We have 8. Okay, that becomes 8. So we have 3/4 x raised to 4 plus we have 13 all over 3 x raised to 3 plus 8x squared plus 4x plus c. So that would be our answer for this problem, okay, of our integral. So that would be our number, I think, number 4. Okay, for our integral. So for number 5, we have the integral of ln of the 2e raised to sine of x. Okay, and then we have dx. So usually, if students saw this type of problem, they are easily discouraged because they think it's really hard, but it's actually not. Recalling the properties of natural logarithm, so we have ln of, let's say, ab. We can rewrite it as ln of a plus ln of b. So in this case, we can rewrite this integral as we have what? We have the ln of 2, that could be our a, because it's multiplied with another function e raised to sine of x. So that can be our a, and this would be our b. So what will happen? We have ln of 2 plus we have ln of e raised to sine of x, okay, and then dx. And if we wish to get the integral of that, that would be by applying the properties of integral, sum of integrals. So we have integral of ln of 2 dx plus integral of ln of e raised to sine x dx. Okay? And take note that ln of e, for example, raised to x, would be, ln of e would be cancelled. That would be simply x. So in this case, ln of e would be cancelled, and the right side of our term would simply become sine of x. Okay, so that's how we solve that. So we know that ln of 2 is a constant. Okay, so we can factor out ln of 2 outside of the integral sign, and then we have this type of integral. So ln of 2 and then integral of dx multiplied by the integral of dx, that is simply x. Okay, and then integral of sine. Okay, don't forget the integral of sine is negative cosine, so this becomes negative cosine of x plus c. Okay, so our answer would be ln of 2 multiplied by x. So in other words, we have this. This is ln of 2 multiplied by x. Not it. It is not inside the ln. Or it can be x ln of 2. Okay? Minus cosine of x plus c. Or it can be also x ln of 2 minus cosine of x plus c. So this can be your answer. Okay? So a lot of people are so afraid, okay, of having that as their problem. Okay, whenever they see that, they panic, no? They don't know what to do. But in fact, upon, if you know the basics of the algebra, it would be very simple for you to solve that type of problem. For number 6, we have the integral of 2y cubed, 2y squared. I'm sorry. That's 2y squared e raised to pi minus y cubed dy. So, in other words, you would think that this is integration by parts. But upon looking here, okay, we have the term pi minus y cubed. This would look like an integration by parts because you have an algebraic y squared here and it is multiplied by an exponential. But before taking into account, okay, of doing integration by parts, you would see a pattern that the exponential is raised into pi minus y cubed. So it is a simple u substitution that it will let u pi minus y cubed, and if we get the derivative of u with respect to y, that would become 0 because the derivative of pi should be 0 because it's a constant. So you have negative 3y squared with respect to y. So in other words, we have negative 3y squared dy. And take note, present in the integral is the y squared multiplied by dy. So you can isolate dy squared all over dy there. Okay? So we have du all over negative 3, and then we have y squared dy. So that if I factor out 2 outside of the integral, that's possible. Okay? I'll be having e raised to pi, let's say, e raised to pi minus y cubed y squared dy. Okay? And we can easily substitute it by the u substitution that we have made here. Okay, so we have 2, and then we have the integral of e raised to u because u is, we substituted it into pi minus y cubed. That is u. Y squared dy is equal to this or equal to this. Okay? That is du all over negative 3. So I can factor out negative 1/3, okay, outside of the integral sign because that's a constant. And I'll be having e raised to u du inside of the integral. So upon integrating e raised to u du, nothing will happen. Nothing's gonna change. It's still e raised to u plus c. Okay? And don't forget that we perform u substitution and we should go back to the original variable. Instead of u, we're going to substitute it back. We're having pi minus y cubed. So we have e raised to pi minus y cubed plus c. Okay? So that would be our answer for this sixth problem out of 1,001 problems solved in integrals. Okay? So, next question for number 7. Find the integral of t squared plus 2t dt all over. We have the 7th root of t cubed plus 3t squared plus 10d. So as you can see here, we have 7th root on the denominator. So if we wish to let u, this is another u substitution. If we are going to observe the denominator, that's t cubed plus 3t squared plus 10. So let's try it that if we let that as our u, why do we have a hint that that would be our u, that this is a u substitution? Because when we get t cubed, the derivative of t cubed, it produces 2t squared or 3t squared, of which in the numerator you have a t squared. So it's more probable, or there's a more high probability that we can use u substitution here because the numerator has a t squared in it. So we have t cubed plus 3t squared plus 10. Okay, as our, let me just rewrite this as in block so we can distinguish. So we have t cubed plus 3t squared plus 10. Of course, if we get the derivative of u with respect to t, that would be 3t squared plus 6t, okay, dt. That would be our du, okay, with respect to t. Okay? So, what are we going to do here is that if I'm going to factor 3 on each of the term here in the du, so we have 3t squared plus 2t dt, of which t squared plus 2t dt is in our numerator. Okay? So that we can now use u substitution. I only want t squared plus 2t dt on the right side of the equation. So therefore, I have to divide both sides by 3 so that I can isolate 2t squared plus 2t. Then we have dt here. So that's it. So we can now substitute. Okay? So we have t squared plus 2t dt equals du all over 3. All over, we have the 7th root of the u. We let t cubed plus 3t squared plus 10 as u. So we have the 7th root because we have what? 7th root here. Okay, so we can factor out 1/3 outside of the integral so that this becomes du all over. So we need to have it in exponential form rather than in radical. So we have u raised to 1 all over 7. And the reason we did that is we can use power formula by negating or getting the reciprocal of that and negating its exponent like this. So you have 1/3, then we have, okay, u raised to negative 1 all over 7 plus 1, then we have 1 all over 7 plus 1, okay, and then plus c. So that would be what? So negative 1 all over 7 plus 1 would be negative 1 plus 7 all over 7. That would be 6 all over 7. Okay? So, That would be negative. That would be 6 all over 7. Okay? So, negative 1 all over 7 plus 1 would be 6 all over 7. So, that would be our factor. So, we have 1/3. Then we have u raised to 6 all over 7 all over 6 all over 7 plus c. Okay? And then, of course, we can substitute or we can simplify this so that we have 1/3 times 7 all over 6. Then we have u raised to 6 all over 7 plus c. Okay, and we can now factor out, okay, or simplify this. So this would be 7 all over 18. Then we have u. Our u would be t cubed plus 3t squared plus 10 raised to 6 all over 7 plus c. So that would be our answer for our sixth problem. Okay. So for our seventh problem, I think. I mean, seventh problem. Okay. So for number 8, we have to try integral of x dx all over, you have x dx all over 3x squared plus 8. So maybe a lot of you will think that we can separate, right? We can separate x dx all over 3x squared plus x dx all over 8. That is not true. We cannot separate that. We cannot do that, okay? Because it's the denominator. So, instead, we can use u substitution here. If you're going to let u 3x squared plus 8 here, so our du, why do we do that? Our du would become 6x, okay? So plus 8, the 8 will vanish away because the derivative of a constant would be 0. So we have dx. So and we have x dx on the numerator. So I would want here is the right side of the equation is only x dx. So we have du all over 6. Then we have x dx. So now we can perform the u substitution. X dx is du all over 6 all over what? 3x squared plus 8, which is u. So we can factor out 1 all over 6, and then we have du all over u here. And then, of course, du all over u would be ln of the absolute value of u plus c. So, but u, we can factor out or we can substitute it back. The u, we have 3x squared plus 8, okay, and then plus c. So that would be our answer for number 8. How about for number 9? Let's try to solve number 9. So we have the integral of cosine of x all over sine squared x. And then we have dx. Okay? So we can simply use the u substitution, okay, in here by letting u as the sine squared x. So that is also equivalent to sine of x squared. Okay? Or simply, we are going to let, without the exponent. Okay? Sine of x only. Okay? So we have sine of x, and then we have du as the cosine of x dx. So the cosine of x dx is already on the numerator. So we can simply substitute it. So we have du, that is the cosine x dx, all over sine of x, which is u, okay? And it's raised to 2, so that we have u squared, okay? So by power rule, we have u raised to negative 2 du. That becomes u raised to negative 2 plus 1 all over negative 2 plus 1 plus c. So our answer would be u raised to negative 1 all over negative 1 plus c. Or in other words, that would be negative 1 all over u plus c. Okay, so we have eliminated the negative sign. So that we have what? Negative 1 all over sine of x, okay, plus c. So that would be our answer for this problem. Okay, so for number 10, and I think this would be the last one. Think this would be the last one. So we have the integral of 4 dx x ln of x. So this may seem really hard, but it's not actually. So we can factor out 4 outside of the integral sign because that's a constant. Okay. So if we are going to rewrite the integral such as it looks like what? It looks like this one. We have 1 over ln of x, and then we have dx all over x. So if we are going, guys, to let u equals ln of x and get the derivative of that, that is 1 all over x, we have dx. So we have du dx all over x. Okay? So we can now perform the what we call the u substitution in this. So that we have 4 integral of 1 all over x. Okay, 1 all over ln, that is 1 all over u. Okay, dx all over x is simply du. So we have 4 integral of du all over u, and that would be 4 ln of absolute value of u plus c, wherein u is the ln of x. Okay, so we have 4 ln of the ln of x plus c. So that's it. I hope that is the first part of our 1001 solved integrals. And I hope you enjoyed this video. If you are new to my channel, please don't forget to subscribe and hit the bell button for notifications whenever I upload some videos. So I promise that I would finish this 1001 solved integral. So far, we still have 991 integrals to solve. Okay, and please tune in for more videos like this, okay? And as well as, of course, many different videos. So please don't forget to like, to share, and to subscribe, to share it with your engineering friends or for those who are taking math. This would be a great help for you, okay? So thank you so much, guys, and thank you so much for your support. And on my 40,000 subscribers, I think I'll be giving away some free books, okay, including the differential and integral calculus. So please do support me by sharing my channel, sharing my page, Facebook page, and sharing this video, okay, to other person who are in need. Okay, so thank you so much, guys, and God bless.